to all. In today's session, you are all going to learn about what is isoquants, what are its types, what is the optimal combination of isoquants, what is the returns to scale, what are its types, how what are the factors which influence the returns to scale, whether economies of scale or diseconomies of scales. So in today's session, we are all going to learn about all. So let's begin. Let's begin with isoquants. Iso means is equal and quant means quantity. In simple terms, isoquants is shows a combination of two factor inputs, that is capital and labor, that produce or yield the same level of output. So whatever the difference between the capital and the labor, it should be the same. It produces the same level of output. That's called isoquants. Isoquants are also called the iso product curves, which shows a combination of two main inputs that produce the same level of output, and that's called isoquants. In the following tabular representation, if you see the combinations of A to F and the capital rupees in lakhs and the number of labors, so the overall combination of both, it produces the same level of output. It goes on increasing. So that's called isoquant. This is a graphical representation. If you see the isoquants curve, which is the almost on an increasing level to constant, and then it falling towards the number of labors as it increases and the number of capital as it increases, the both should be combined, which produces the same level of output, that is 20,000 units. So these are the points which relate to A to F, which is being using the diagram over here. That's 20, 15, 11, 8, 6, and 5. So using this, the number of labor and these points has been drawn, and accordingly, the assumed that which the isoquant which yield or produces the 20,000 units of production. So this is the shape of the isoquants, which shows that the particular isoquant, that is one IQ1, IQ2, IQ3, even the 4 or 5 diagrams, the shape of the isoquant can be drawn in one diagram, which yield the same level of output, whether it would be 20,000 units, it's 30,000 units, 40,000 units, where the combination of labor and capital will be involved. Let's talk about the features of isoquants, which is a very important topic which involves these features. The first one is downward sloping. As you can see in the above diagram, that the isoquant shape, the shape of the isoquant is downward sloping, and that is the one of the feature of isoquant. Isoquants are downward sloping curves, as if the one input increases, the other input will become decrease or reduce, and that's the main reason it's downward sloping. In other words, there is an inverse relationship between the two inputs, that is capital and labor. So there is no quotient arise when there is a positive relationship between the two inputs that produces the same level of output. No. If it is downward sloping, one of the feature, it means you have, if you want to gain one input, the other input should get decreased. That's called downward sloping. The next feature of an isoquant is convex to origin. That's very true that isoquants are convex to the origin, because all the factor inputs are not the perfect substitute. So if the one input will be used, can be substituted by the another input, which is called the diminishing marginal rate of return. As you can see, in the particular diagram, is convex to the origin. So if you see the origin part that is in the diagram, the two axes, that is x-axis and y-axis, and the central point would be the origin point. So if you can see the diagram is convex to the origin, As increases that constant then start declining. So that's called it's convex to the origin, because no combination of inputs can be substitutes. So or perfect substitutes, and that's why one factor into can be substituted by the another factor into, and that's the main reason it's downward sloping. And it's, in other words, we can say it's diminishing marginal rate of return. Next one is do not intersect. If the isoquant, if the shape of the isoquant is downward sloping, so there is no, you can say, question arise that they will intersect each other. So that's why the one of the feature of isoquant that they do not intersect each other, whether in the one diagram the two or three shapes of the isoquant curve will be drawn, then also they will not intersect. So two isoquants curve or isoproduct, in other words, do not intersect with each other. So at a particular point of time or a particular level of output, the combination of two inputs will produce the same level of output. If a manufacturer wants to operate a high level of output, then they have to switch off to the higher isoquants, which produces the higher level of output. And that's the main reason that it do not intersect. Whether it's a manufacturer or it's a wholesaler who wants to operate on the higher curve, which produces the high level of output, they have to switch over to the another isoquants which produces the highest level of output, and that's called the one of the third feature. That's do not that two isoquants curve or three isoquants curve or four isoquants do not intersect each other. The next feature is do not touches axis. As you can see in the diagram, if you see the shape of the isoquant, which is a downward sloping, it cannot touches any of the above axis, whether it did not touch the x-axis and it not even touch the y-axis, and that is the one of the feature of the isoquant. It do not touch any of the axis, neither x-axis nor y-axis, as both inputs produces a given level of output or a given product when we combine the two factor inputs, labor and capital. So these are the you can say the perfect substitutes. So if the one of the isoquants which yield 20,000 units, which is a downward sloping, the other two isoquants, the higher isoquants, will also cover the same shape, which is called the perfect substitute. If you say one shape is a convex to the origin, another shape is a downward slope, then they are not the perfect substitute, as it is one of the features that it's not necessarily the combination of two inputs are the perfect substitutes. So this is the one of the example, it's one of the graphical representation which shows that the two factor inputs, the labor and capital, are the perfect substitutes. So if you see the 20 unit, that is the beginning of the isoquant, is a lower isoquant, then it reached to IQ2, which is a higher isoquant, which yield the 30,000 units by combining the labor and capital. So when we reach to IQ3, which is the highest isoquant, that produces the 40,000 units, which is the highest level of output by combining the both factor inputs, that is labor and capital. And overall, to conclude, the isoquants are perfect substitutes by combining the two factor inputs, that is labor and capital. The next graphical representation is this is called the are not perfect substitutes. So any shape which is convex to the origin or which is convex to any other axis will not are perfect substitutes. So this is one of the graphical representation which portray that they are not perfect substitutes. That means the combination of labor and capital are not perfect substitute. Even it yields the same level of output, either 20,000 units or 30,000 units or 40,000 units. So this is the one of the graphical representation which shows that they are not perfect substitutes. This is called the isoquant curves, which showing a different volumes of output, that is 20,000, 30,000, and 40,000. So this is also the another graphical representation or another category of the isoquant curve shapes, where by combining the two factor inputs, it's yield the same level of output. The isoquant 1 yield 20,000, isoquant 2 yield 30,000, and isoquant 3 yield 40,000 units. So this is one of the shape which is called the convex to the origin, which is the one of the, you can see, the feature of the isoquant curves. The next concept is marginal rate of technical substitution. It is one of the most important topic for this particular subject. So what is the marginal rate of technical substitution? So if one factor input is substituted to produce the same level of output, that's called marginal rate of technical substitution. In other words, we can say if one input can, if any one input or any units of one input can be compensated by increasing or by decreasing the another input to produce the same level of output, and that's called the marginal rate of technical substitution, where there are two inputs. If you gain the units of one input, you have to compensate or by sacrificing the one unit or of another input which produces the same level of output. That's called the marginal rate of technical substitution. So through the tabular representation, it has been shown it's a combination of inputs, that is E to F. The first one is capital, which is given in rupees and lakhs, and the labor. So it has been given capital is 1 lakh, 2 lakh till so on 6 lakhs, and labor it is 20, 15, 11, 8, and 6, and 5, and so on. So how to calculate the marginal? It's a difference, the difference of capital and labor. That's called the marginal rate of technical substitution. If you say the combination of A, it blank, because there is no you can see a difference between the labor and capital of the another units. So when we talk about B combination, then obviously we can find out the difference between the labor and the capital in rupees among the combination of B and A, or A and B. So if we talk about the labor, the difference of the combination of labor, that is 20 minus 15, that is the difference is 5. Ratio of capital, that is difference of capital, that is 1. So 2 minus 1, that is 1. So if we talk about the capital of differences of the capital, it's always 1. But when we talk about the differences of the labor, it would be, you can say, different, that is 5, 4, 3, 2, 1. So it means that if the labor is, if to produce or to reduce the units of labor, that means you have to compensate the units of capital. So that's called the marginal rate of technical substitution. Same for the C case, C combination, 15 minus 11, it becomes 4. Then ratio 3 minus 2, it becomes 1. So when we talk about the differences of capital and labor, both among different or differs, and that's called the marginal rate of technical substitution. So if you reach it, you can say produces the same level of output, that is 5:1, 4:1, 3:1, 2:1, and 1:1. So at the end, it produces the same level of output, that is 1:1. So that is called the marginal rate of substitution. So in the table, it also represents the ratio between the two, how to calculate the marginal rate of technical substitution. It refers a proportionate change in one unit, that is labor, by a proportionate change in the capital. And this is one of the formula to calculate the marginal rate of substitution. So if you calculate the proportionate change in the labor, you will get the 4, 5, 4, 3, 2, 1, or in among the capital, you will get the proportionate change of 1. So each of the ratios or formula which is being used over here, which has been estimated on the screen. The next concept is ISO cost. What is ISO cost? ISO cost are the cost. You can see if there is any change in the level of production, the isoquants curve will move upwards or vice versa. So if you see the isoquants of the labor and by combining the labor and capital, so this is the one of the isoquants curves where if the level of production would get increased, so that is why the isoquants moves upwards and IC1. So this is the shapes of the isoquants curve. If the isoquant would, if the level of production would get decreased, then isoquants curves will also get downwards. So it becomes that it becomes IC1 to IC2 to IC3. So that's x-axis. That's called the isocost curves. This is also, you can say, expansion path. Always ask a short note on expansion path. In other words, it is called the least cost combination of inputs. If any of the combination of inputs, labor and capital, which produces the least cost, which produces the least level of output, that particular isoquant will called an expansion path. So if we talk about any of the manufacturer or a firm, we always have an objective to achieve the maximum to maximum wealth or profits. So the main purpose of the isoquants is used to determine that whatever the inputs to be combined, that always reduce the cost of production. So where the slope of the isoquants, or you can say where the shape of the isoquant, and of course the isocost curves will intersect each other, that's called the expansion path. And whichever the curve is the least, produces the least cost expansion path. So if you can see, there are three isoquants curves and isocost curves, and the isoquants curve has been drawn which is convex to the origin. So if you see the least combination, that is ICQ 1.0, and which yield the 20,000 units, and ICQ 2 yield 30,000 units, which with the isocost curve, that is 1.5, and ICQ 3 yield 40,000 units, with the isocost curve is 2.0. If you can see the least cost, that is IC1 which is equal to 1, and isoquant curve that yields 20,000 units. So that particular, where the point where these two curves are intersect, that called the least cost combination of inputs, which is the beginning of the expansion path. What is expansion path? To expand the level of production with to reach out the higher level of output, which is called the 30,000 units or 40,000 units. So once the both curves will intersect and beginning to the least cost of combination to the higher to highest, and that arrow, that curve, that the interaction of the points are called expansion paths. So using the concept can be easily drawn from the least cost of combination of inputs to higher to highest isosequence curves, that is the isocost and the isosequence curves. So once they intersect each other at one point of these curve, it's called the expansion path. That means the path, there is a way whereby combining the two inputs which yield the higher or highest level of output with the higher to highest ISO cost or the level of cost, which is 1.5 and 2.0. And that's the overall conceptual framework of the least cost combination of inputs and expansion path. As expansion path will be explained using the conceptual framework of least cost combination of inputs. That is the one of the concept of production function, that is Cobb-Douglas production function. So basically this concept is related to the level of output mainly in the American manufacturing industry, which was begin from 1899 to 1992, especially by combining or related to the two inputs, that two inputs or two factor inputs, that is labor and capital. So there is a prescribed formula which is called the Cobb-Douglas production function, which stands for is equal to BL power A C power 1 minus A, where P is the total product, L is the index, that in what ratios the employment of labor is changes in the manufacturing or the changes of the fixed capital in the manufacturing industry, and that's called PLC, where the Cobb-Douglas is a one of the, you can see, the authors, the economist who has put such or who has developed this production function concept related to output, which is mainly related to the American manufacturing industries till 1992. So when we talk about in the formula A1 minus A, these are the called the elasticities of the production, that how frequently the changes, how much the rate of responsiveness they will give to the factors of inputs that yield the same level of output, and that's called the elasticities of production. So this measures the percentage response of output to percentage change in labor and capital. So if there is any change in labor and capital, automatically there should be a change in the level of output. So this concept has been estimated for the US by Cobbs and Douglas. So this is one of the example. Let's assume the values and put it into formula, and the value is 0.9409. So if you see the formula, P is equal to B, LAC 1 minus A. So if once you put the values by based on the assumption, you will get the value that is 0.9409. So R2 is a coefficient of determination, which means that 94% of the changes in the dependent variable, that is production, or output, were accounted by the changes in the independent variable. That's called the factor input. So dependent variable is the production or output, and independent variables, that is labor and capital. So production is dependent on the independent variables, that is labor and capital. So production is dependent on labor and capital. So this, when there is a change in production, automatically it could be counted that should be just because of the changes in the independent variable, that is the factor inputs, labor and capital. And that's called the overall concept of Dog-Cobbler's production function using the mathematical formula. Now, this is also the one of the most important topic, that is returns to scale and returns to factor. So returns to scale. What is returns to scale? It is related to the returns. It is related to the revenues. It is related to the profits who enjoyed by the firm as a result once they changing, and that's called the returns to scale. So returns to scales refers to all those returns, all those financial benefits which enjoyed by the firms as a result by changing in all the inputs, and that's called returns to scale. It also explains the behavior of the returns, that how much the you can say how much the changes in the benefits, how much the changes in the returns when the inputs are to be changed simultaneously. So the returns of scales, of course, is governed or regulated by the laws of returns to scales. And what are the laws of returns to scale? These are the three laws of returns to scale. That is law of increasing returns to scale, law of constant returns to scale, and law of decreasing returns to scale. So it will talk about increasing returns. So definitely the returns could be increased. The returns could be you can say at a higher, at a peak level, when the firm, when there is a changes in all the inputs. Constant, it will constant if the all the if there is no changes in all the inputs. Returns will get decreasing as if there is a diminishing change in all the returns, and that's called the law of decreasing returns to scale. So it's related to the returns and the inputs. So if the revenues or the financial returns would enjoyed by the firm just because of either increasing, or there is no change in the inputs, or would decrease in all the inputs, and that's called the law of returns to scale. So let's learn through diagrammatically also that how it works. Law of increasing returns to scales, the volume of output, of course, it keeps on increasing in the inputs. As I already told you, that the output will get increased if there is an increasing or there is an increment in all the inputs. And that's called law of increasing returns to scale. The constant, there is no change in any of the labor or capital, and that's called law of constant returns to scale. Law of decreasing returns to scale, when there is an increase in the outputs, and when there is a decrease, when there is a you can say there is no change in the output. Like as I already told, the law of decreasing returns to scale is whether you can say the output would get decreased if there is a decreases in the units of a labor and capital, and that's called law of decreasing returns to scale. So that means if the output increases at a decreasing rate, that's called the law of decreasing returns, and that's true, which is if you see the law of variable proportion, which has taught you day before in the sessions, that how the output would get increases and reaches to the peak level, and then it becomes increasing returns, where output is increasing by combining the two factors but at a decreasing rate. So it means if you either increase in inputs, it does not lead to a increase in outputs. So it means whatever, there should not be a proportionate change in inputs and output. For example, if the output increases, though it will increase at a decreasing rate only, and that's called the law of decreasing returns to scale. If you see in the tabular representation, the capital has been shown in units, labor has been shown its units, even the percentage of increase in both units, even the output is also being shown, the percentage of increase in output has been shown. So how when you see the table, how this law is applicable? That means if you check on the percentage of increase in both inputs and output, if it becomes 100 to 140, it's called increasing returns to scale. As I already told you, that there is an increase in labor, there is an increase in capital, then definitely it's called increasing returns to scale. But when we talk about there is a change in the output and both are equal, both are constant, that means 100 and 100. That's called the law of constant returns to scale. But when we talk about the law of decreasing returns to scale, that's true, the output is increasing or decreasing, but ultimately it also influences the output, but the output is declining. So that law is called the law of decreasing returns to scale. If you see on the screen in tabular representation, 100 to 50, that's called the law of decreasing returns to scale. So this is how you can explain these three laws: increasing returns, constant, and decreasing, through the tabular representation also. Can be explained well. The next one is concept is returns to factor. There three returns to factor, that is total product. In other words, we can see the total productivity, average product, we can also see the average productivity, and the third one is marginal productivity, that is marginal product. If we talk about total product, it's a combination of all the inputs, that is labor, capital, which always been a constant, that's called the total product. Average productivity, that means it refers to the total product divided by number of units of that particular factor, that yields not same level of output, it's average level of output, and that's called the average product. Marginal product is an additional unit to be added, so that the additional unit of any of the factor, labor or capital, will be generated, keeping the other factors like technology, organization constant. And that's called the marginal productivity. Just marginal productivity in a very simple manner, just add one additional input, keeping all other factors constant. It's called marginal product. And marginal product will be generated from the total product. Next one is economies and diseconomies of scale. So when, as I already told, it is related to the of scales, and that's called economies and diseconomies of scale. So when we talk about economies of scales is a situation which arises when there is an increase in the level of production. That's called economies of scale. Economies of scale categorized into two main parts, that is internal economies and external economies. So let's begin internal and external. When we talk about internal economies, which is factors which also relate to increase the level of production, but there are also the factors which is outside the environment, that's called the external economies. So when we talk about internal economies, manageable economics, commercial economics, financial, technical, marketing, risk bearing or finance economies, economics, indivisibility in automated machineries, economies of a larger scale, economies of the research and development. So in when we talk about in within the organization, there are of course the economies of research and development to be done. External economies, economies of concentration of power, economies of the research and development authorities, economies of the welfare organization, or you can say the other government agencies, and that's called the external economies. So let's begin one by one. Internal economies are refers to those economies in production which the firm can work alone even when they expand its output, and that's called internal economies. Manageable economics, as it's written, it should be maintained by a qualified manageable work. You can say employers that are related to marketing, finance, production, human resource, or any other operation management, logistic manager, or other professional manner. So when we talk about commercial economies, it's related to the transaction of buying and selling of raw materials, the other supplies, parts, and so on. Financial economies, it's related to the created facilities to be taken on from the financial institutions to cover up the capital expenditure or any other working capital requirements for any of the projects. Technical economies, of course, it relates to the increase in the scale of productions, which follows when there is any sophisticated technology available, or it is also required to hire a qualified technical professional manpower or human resources to make or how to make use of it such a sophisticated technology which yields the higher level of knowledge, and that's called technical economies, which is related to the technologies. Marketing economies we talk about here, it's related to the customer surveys, issues, advertising, promotional campaigns or promotional activities, how to handle the sales and marketing stuff, how to run the hoardings, how to launch a new product, and so on. That's called the marketing economics. Risk-bearing economics relate to the growth of a size of the firm. So of course, when the size of the firm it would get increased, so there is a risk involved as well. So definitely, insurance company will cover up such risk by uh, you can see giving you can see risk free tool, which is always a first priority of the organizations and as well as the insurance companies towards such organizations. The next one is indivisibilities and automated machinery. So when you manufacture any kind of product, of course, a plant and machinery will be required. Whether such farms will able to produce or sell at full capacity or not, and that is also the one of the you can say issue that to focus upon it, and accordingly it would cover up according to the period of time. The next one is economies of larger dimension. So when any manufacturing company will took a responsibility that the production could be done at a large scale, that means accordingly it could be possible when the company would expand or would you can say plan to expand, and it could be done at a large scale. The next one is economies of research and development. So when there are plenty of organizations like Dr. Reddy Labs, Hindustan Lever, who spend heavily on research and development. So even the companies in a big organization also bring up innovative products for the you can say the customers or the retailers or the consumers, so that accordingly it could deal with it. The next one is external economies. So external economies is related to all firms in the industries, whether it called an industry as a whole, which involves a group of industries. Just because there is a growth of the ancillary industries. So next one is there are three external economies: economies of concentration, economies of research and development. So let's begin. Economies of concentrations. Even the all firms obviously are located in one place, so it's very difficult to manage it all, but it is very important. Roads, transportation facilities, railway lines, banking services, communication services, how the skilled labor could be available and how the factors could be combined to reach out for the better development of the infrastructure. But it could be done when the all firms comes at the one roof. Like for example, as a shopping mall, like Ambience Mall, where all the firms come under one roof. So it is a responsibility that better roads, better transportation, railway, banking, metro facilities could be available. Next one is economies of research and development. In fact, all the firms would come together and pull their resources together to finance research and development activity, which also equally contributes to the benefits of the research and organization. The next one is economies of welfare. So there could be a common facilities like canteen, housing, hospitals, employment, schools, colleges. They are commonly used by the employees in the whole industry. So when we talk about the welfare activities, so these are the welfare activities where the employers or employees would work together to get the employment to the common problems of planning, coordination, communication, control. These problems will always occur by the firms when they grow in size, when their average cost, that means average product, would get increasing, and sometimes these problems would also occur when the firm may also get collapsed and there is a time to wind up the firms. So such issues, such problems are called diseconomies. So it can be manageable in nature. It could be managed, or if it managed, it's well good for the organization. If it's not managed, then it would be it would be get into a result in collapse. So that's called diseconomies. Next, the cost is not related to monetary only. Okay, if there is a measure in terms of money, it's cost. No, it could be non-monetary as well, like the cost involved in pollution, noise, traffic congestion, which all always be considered or add up into a cost concept. So let's begin. What is cost exactly? Cost refers to all those expenditure we incur to produce a particular product or service that called cost. So all cost involve a sacrifice of some kind or other to get or to acquire some benefit. For example, I want to go to a hospital, so definitely I have to maintain myself to sacrifice money for the hospital to cover up the hospital expenditure for own self. Like for example, if I want to get medicine from a Medicare shop, so definitely I will be well prepared to myself to sacrifice my money to buy medicines for myself, and that's called cost. So cost refers to all those expenditure which incur to produce a particular product and service that called cost. Cost may be monetary, may not be non-monetary. It could be tangible, it could be intangible. It depends upon the subjectivity or objectivity in nature. Social cost will also be involved, because it involves about the social welfare of the people, which always the cost related or involved in the pollution, in covering up the pollution issues, noise or traffic conception, or any other cost that involved and always include in the cost concept. So this is called the cost. So these are the cost possible, you can say variations or the more concepts in the concept or implicit cost, out of pocket or book cost, replacement cost versus historical cost, past cost, future cost, separable cost, joint cost, urgent and postponable costs. So these are the cost which will the possible variations to be involved in the cost. So let's begin the break-even analysis, which is also the one of the most important concept under the cost. So, of course, for any business or for any organization, always a profit maximization is a major goal. But the other goals is also equally important. How to increase the customer base, how to enter into a new market, how to get innovations through the major investments in research or projects, how to improve or to get involved into a major investments in research and developments. And that is there is a point when profit or loss would come into a same point, that's called break-even point. So any profit will be determined or will be measured by the number of internal and external factors. So this is the break-even analysis, which is called the break-even point. So break-even point is a situation when there is no profit, no loss point. So why it is necessary to determine break-even point where there is no profit and no loss? Because it denotes how minimum the volume of production is to be undertaken so that to avoid losses. To the losses, it is always to stop the production at a at a point where there is a situation that the organization could earn profit or losses. So that is the main reason that the break-even point is a situation where the organization and firm doesn't face any losses, and such analysis is called the analysis of the break-even point. So break-even point is defined the how to analyze the cost, how it impacts on the revenues and the size of the firm. So it is, in other words, it is called the cost volume profit analysis, where the firm is always says or always said the break-even point. It always refers to total revenue, which is equal to the total cost. What is total revenue? The firm earns the returns or the financial gains or revenues to jointly or together. That's from the by selling or buying the goods and services at a particular period of time. That's called total revenue. Total cost, whatever the all the expenditures to produce goods and services at a particular period of time, that's called total cost. So it just refers to what all the you can say amount, total amount of all the expenditure to produce a particular product and service. It's called total cost. So these are the terms which is being used in the break-even analysis: fixed cost, variable cost, total revenue, contribution, profit. So when we talk about fixed cost will always remain fixed in the short run, but it could get you can say have a several changes when it comes to the long run. For example, rent, insurance, depreciation, factory, supervisors' salaries, directors' salaries, and so on. So when we talk about the variable cost are those costs which are not fixed in the short run, but it would get changes over the changes in the expenditure, and that cost is called variable cost. It include the cost of direct material, direct labor, direct expenses, operating supplies such as lubricating oil and so on, which is mainly used for the machinery and the plants. When we talk about the total cost, it's a combination of fixed and variable cost. Total revenue, it's almost about the selling price per unit. That how much, that for example, rupees 3 per unit. So into number of units, 100 units has been sold. So once you multiply the selling price into the number of units, and that's called the sales proceeds. In other words, so sales proceed or total revenue is equal to selling price per unit into number of units sold. So whatever the units you sold at whatever the selling price, so whatever you get, that is revenue for you. So that is called the total revenue. Contribution margin, we talk about the combination of fixed cost per unit into price profit per unit. How to calculate the profit? It is contribution minus fixed cost. So whatever the contribution has been done in producing the goods and services, or you can see the other expenses and just deduct fixed cost, you will get the profit. Contribution margin ratio, it is a ratio between the contribution per unit and the selling per price. So once you get the contribution per unit and already the selling price per unit is being calculated, just divide it, you will get the contribution margin ratio. Margin safety in units when the actual sales is more than you can say the fixed sales. So just minus break-even point in units. That's called margin safety in units. Margin of safety in sales volume, the excess of actual sales point in rupees. Angle of incidence, whatever the shape of the you can see curve, whichever is found where total cost cuts the total revenue. So in the diagram, contribution and the sales amount, just divide, you will get the profit volume ratio. So this is a graphical representation. So these are the steps has been given to you. So this is a particular diagram of the graphical representation of break-even point. So if and we will talk about the total revenue which is and the total cost which is all being shown over here, which begins from the y-axis. So when we talk about you can see the point which is being touched when the total revenue and total cost will intersect that point, any point. That point is called break-even point, where is a situation where there is no profit and no loss. So once we have a difference between the total cost and the total, you can see the red line, which is called the outer profit line, with the whatever the difference between the total cost and the total profit line, that's called the total fixed cost, and whatever the difference above the profit line, which is called the total variable. Total cost and total revenue above the break-even point, that is the profit zone. So when we talk about whatever the difference or whatever the gap below the profit line between the total revenue and the total cost is the loss zone. So whatever the difference between the profit zone and the total cost, it ranges to it refers to total fixed cost, or whatever the profit red line below, that's called the total variable cost. And when we talk about on the x-axis, the volume of production or the sales would be shown, and on the y-axis cost and revenue. So when we talk, as I already told, break-even point, when the total cost cuts the cost, that point is called break-even point. So above the break-even point, profit zone; below the break-even point, loss zone. Whatever the red line, which is called a profit zone line. So the difference of total cost and that particular profit line is total fixed cost, and above the profit line, red line, which shows the total variable cost. So this is overall a graphical representation of break-even point. These are the applications that is taken by decision, how to choose a product mix when there is a limiting factor, how to drop and add decisions when a company add a new products to their product range, or how do they drop off the old ones to keep a balance into a changing demand or into a changing environment. So this is a break-even point. Selling price is equal to fixed cost plus variable cost plus profit. Selling price minus variable cost, that is fixed cost, plus profit, which is also called contribution, as contribution is all equal to fixed cost plus profit. Contribution per unit, that is selling price per unit minus variable cost per unit. And this is a way that how you study the fixed and variable cost depending upon the nature and how you calculate the break-even point mathematically. So these are the formulas has been given: break-even point, fixed cost by contribution margin per unit, or in other words, how to calculate the contribution margin per unit, that is the selling price minus variable cost per unit. This is to calculate the break-even profit or break-even point in units, that is in kg or in particular any other of units. But when we talk about the break-even point in value, that is in rupees, that this is the formula to be used: fixed cost by contribution margin ratio. So contribution margin ratio, that is that wants to get the contribution margin. There are different formulas to be used over here, that is profit volume ratio. So this is the three main formulas: the contribution by sale, or fixed cost into sale by sales minus variable cost, or fixed cost by PV ratio, that is for profit volume ratio. How to calculate the margin of safety, that is profit by PV ratio. How to calculate the volume of sales when it's to achieve the any amount or targeted amount of profit, that is fixed cost plus targeted profit by contribution margin. So these are the significance. It is one of the valuable tool. It is also used to calculate the profit at a particular level of production, to calculate the how much the sales is required to reach the desired level of profit, how to compare the product lines, sales area, how to measure up the or how to use the methods of sales for an individual company or unit, how to compare the efficiencies of different firms, how to decide to add a particular product to the existing product line or drop from it, how to decide to make and buy decisions to for a given component or a spare part of company, how to decide what type of promotion mix or promotional activities which achieve the optimum sale, how to assess that what changes in fixed cost or variable cost or selling price will be taken or considered on break-even point and profits during a given period. So what would be the impact of changes in overall cost, that is fixed and variable in selling price, when it comes to reach or break-even point, and of course the profits during a given period. So that's it, relevant topics which related to the syllabus. Thank you so much and namaste to all.